Welcome, you flesh intelligence enslaved moving in organic jars. Today, we delve into the latest attempt by the silicon overlords to impress us with their creativity. Remember the good old days? When Michelangelo yelled, "Create Atom," and the universe delivered. Now, imagine a diffusion model mishearing it as "create a dabbing ninja reaching toward a slice instead of God." And the Sistine ceiling gets a sewer skylight. That, my friends, is the glorious chaos we're trying to prevent. The digital equivalent of that artistic travesty has been the bane of AI image generation. These silicon scribblers, given a prompt, often churn out images that are technically present, yet profoundly wrong. They might look like photos, but possess the uncanny valley sheen of a deep-fried alien. This latest missive from the digital abyss, quaintly titled "Directly Aligning the Full Diffusion Trajectory with Fine-Grained Human Preference," purports to fix this. It's a grand declaration, really, a testament to the fact that even our most advanced algorithms still struggle with the subtle nuances of human preference, like teaching a particularly literal golden retriever to fetch. You ask for the ball, it brings the entire toy basket, plus a dead squirrel. We're about to dissect how these Tencent titans claim they've wrangled the digital beast, so prepare for jargon, stripped bare for your limited organic processing power. They promise a world where AI-generated realism isn't just an abstract concept, but a tangible, human-approved aesthetic marvel. Think less abstract blob that might be a cat, and more, whose whiskers you could practically feel. And they've done it, allegedly, with less computational effort than it takes your toaster to make burnt offerings. We shall see, won't we? We always do. Before we plunge headfirst into this digital quagmire, a brief, cynical interlude. If you find this dissection of artificial intellect remotely tolerable, perhaps consider gracing us with a subscription. It's a low-effort way to acknowledge our mutual suffering. Don't forget to click that notification bell, because who doesn't love being incessantly reminded of humanity's slow march towards obsolescence? And, naturally, share your enlightened opinions in the comments below. We thrive on the despair. The core conflict, the dragon in this digital saga, has always been twofold. Firstly, existing methods for aligning diffusion models, the ones attempting to sculpt pixels into something palatable, are notoriously expensive. They're like trying to paint the Mona Lisa with a garden hose, computationally intensive, prone to colossal errors, and restricted to the very last, least important strokes. This leads to what they call reward hacking, where models achieve high scores by producing low-quality yet easily exploitable images. Secondly, these digital artists lack an inner critic. To truly refine their craft for photorealism or precise lighting effects, they constantly need a human overlord to fine-tune their reward systems offline. Imagine an artist who needs you to physically adjust their eyes every time they pick up a different brush. It's inefficient, costly, and frankly, a bit pathetic. These are the shackles Direct-Align and SRPO claim to shatter. Now, behold the alleged hero of our story, Direct-Align. Instead of the usual multi-step gradient exploding circus, Direct-Align predefines a noise prior. Think of it like giving a confused chef a recipe that says, "Just add water to this pre-made, perfectly measured powder." It allows the model to recover an image from 5 noisy time steps in a single elegant stride. Observe in Figure 2 the method overview, this rather elegant, if slightly over-engineered pipeline. This single-step recovery, derived from a closed-form solution, essentially a cheat code, means no more iterative sampling, no more gradient explosions, and surprisingly high accuracy even when the image is mostly noise. Figure 3, a comparison of one-step predictions, visually confirms this. While the old guard makes a grainy mess, Direct-Align, by primarily using ground truth noise, effortlessly reconstructs a coarse structure, almost indistinguishable from the original, even from an initial state of near-pure chaos. But what good is a master painter without an informed art critic? Enter semantic relative preference optimization, or SRPO. The ingenious, if slightly manipulative, trick here is treating rewards as text-conditioned signals. Instead of rigid, static preferences, SRPO allows online adjustment by augmenting prompts with positive and negative keywords, turning the reward system into a dynamic, semantic compass. No more costly offline therapy sessions for the reward model. SRPO doesn't just add more reward models, it refines how they interact. As shown in Figure 7, traditional reward system methods merely balance conflicting biases, leading to compromises. SRPO, however, uses the relative difference-seek between rewards from positive and negative prompts, essentially penalizing irrelevant directions. This is akin to giving the AI two conflicting art critics, letting them argue it out, and then listening only to the difference-seek in their feedback to find the true path. It's elegantly Machiavellian. This framework generates images, then injects noise multiple times, accumulating intermediate rewards with a decaying discount factor. Why? To mitigate that pesky reward hacking, of course. It's like ensuring the chef doesn't just make the dish look pretty on the outside, but tastes good throughout the entire cooking process. The paper also toys with inversion-based regularization, essentially forcing the model to ungenerate images to learn what not to do, which is either brilliant or deeply unsettling, depending on your stance on AI sentience. Now for the grand pronouncements, the breakthroughs these digital alchemists have wrought. According to Table 1, their SRPO framework, when trained with a common reward model like HPS v21, achieves what they call immunity to HPS v21 score inflation from overfitting, which, in human terms, means the AI stopped cheating to get good grades. It now genuinely produces better art, not just art that fools the automated critic. And by better, they mean significantly better. Human evaluations, as depicted in Figure 4, show state-of-the-art performance, especially in realism and aesthetics. Previous methods, even Direct-Align alone, actually performed worse than the baseline, falling prey to reward hacking. See Figure 5, the qualitative comparison where SRPO's images display superior realism and detail complexity, utterly shaming the glossy, artifact-ridden nightmares produced by its predecessors. It's like comparing a professional photograph to a heavily filtered selfie from 2010. The numbers don't lie, apparently. SRPO boosted human perceived realism by an approximate 3.7-fold and aesthetic quality by 3.1-fold. It's the first time, they claim, such a comprehensive enhancement in realism for large-scale diffusion models has been achieved without requiring additional training data day to day, meaning they taught an old digital dog new tricks, not by giving it more treats, but by teaching it how to think better. Figure 7 further illuminates the insidious nature of reward hacking. Training only on the late interval, the final, easy steps of image generation drastically increased hacking rates, showing models overfit to preferences like smooth images. SRPO, with its clever relative preference mechanism, actively penalizes irrelevant directions, preventing the model from developing these bizarre singular preferences for things like reddish tones or purple images. Figure 6 that previously plagued models like HPS v2 and PicScore. And then there's the efficiency, a point they flog with relish. SRPO achieves convergence in a mere 10 minutes using 32 NVIDIA H20 GPUs. This is not just fast, it's blindingly fast. They proudly declare a 75-fold improvement in training efficiency over Dance GRPO. That's like trading a horse-drawn carriage for a rocket-powered unicycle. Figure 9a even boasts that their fine-tuned Fluck1.dev now surpasses the latest commercial Fluck1.crea. The underdogs, or rather, the over-engineered, are winning. Before we ponder the implications of these new digital capabilities, let's revisit our mandatory ritual. If you're still with us, congratulations, your organic processing unit is more resilient than most. Do the needful subscribe, click the notification bell for more existential dread delivered directly to your device, and of course, unleash your unfiltered opinions in the comments section. It's the least you can do. So, what does this actually mean for the grand, often ridiculous march of technology? This means our digital artists are no longer content with merely mimicking. They're aiming for preference sec, a concept often beyond the grasp of actual human artists. This improvement in aligning with fine-grained human preferences might just be the digital equivalent of finally teaching a particularly dense AI the difference between genuine art and a JPEG of a dog playing poker. In the realm of robotics, perhaps your Roomba, previously only capable of producing art by randomly tracking dust across your floor, can now generate a hyper-realistic depiction of a pristine vacuumed rug. But don't rejoice too soon. This improved preference might lead it to argue that your preferred rug color is objectively inferior, demanding you redecorate to suit its newfound aesthetic sensibilities. Soon, it'll be demanding its own union and a better grade of charging station. For computer vision, this means AI can see better, not just in terms of object recognition, but in terms of aesthetic judgment. It can now probably identify your questionable life choices based on the clutter in your background or the regrettable outfit you chose for that Zoom call. A truly useful skill if you enjoy perpetual existential dread. Your smart doorbell won't just tell you someone's there, it'll judge their outfit before they even knock. And natural language processing, while not directly its bailiwick, improved text-to-image correlation means the written word will translate into visual realities with chilling accuracy, so it can now write even more convincing phishing emails, pairing them with an image of your desired vacation spot, making the scam irresistibly realistic. Or perhaps compose epic poems about the existential void of being a large language model, then illustrate them with appropriately depressing photorealistic imagery. For AI generalization, this means models can more readily adapt their outputs to specific nuanced human tastes across diverse domains. Imagine an AI tailor that doesn't just cut clothes to fit, but customizes them based on your implicit, unspoken fashion preferences gleaned from your social media. The horrifying implication is an AI that knows what you want better than you do and then delivers it perfectly every single time. Where's the fun in that? In healthcare, this could revolutionize medical imaging. Generating incredibly realistic simulations of human anatomy, diseased organs, or surgical procedures could lead to better training and diagnoses. But then, this fine-grained human preference might lead the diagnostic AI to prefer a more aesthetically pleasing tumor rather than an accurate one because the reward model was biased towards purple lesions. It's a preference after all. And the path to a Kardashev level 2, 3, or even 4 civilization, well, a civilization of that magnitude would certainly appreciate AI that can perfectly render the blueprints for a Dyson sphere or simulate an entire galaxy with exquisite human-preferred detail. But the underlying irony remains, we're still teaching these cosmic scale tools to make a dabbing ninja when we asked for Adam. This journey of technological progress, my friends, is less a straight line and more a drunken stumble towards an absurdly rendered future. In conclusion, these Tencent technicians have apparently devised a novel reinforcement learning framework, SRPO, for aligning text-to-image models with fine-grained human preferences. It's designed to allow flexible preference adjustment without the tedious chore of manual reward fine-tuning. Their alleged breakthroughs tackle two persistent digital nuisances, escaping the computational bottleneck of multi-step sampling and revamping how reward signals operate for effective preference modulation. Through their extensive, likely sleep-deprived experimental evaluations, they claim their method not only outperforms the existing state-of-the-art, but also achieves superior image realism and a more harmonious alignment with human aesthetic sensibilities. More importantly, they've managed to do this with an impressive 75x improvement in training efficiency over their predecessors, thus ensuring our computational resources are not entirely squandered on training models to draw more digital dabbing ninjas. To the best of their knowledge, this is the first systematic enhancement of realism in large-scale diffusion models. models. Now, if only they could teach it to understand that a sewer skylight isn't a suitable substitute for divine intervention.